Hello, and welcome to the TEAS 7 exam review for the chemistry section. My name is Professor TK the Chemist, and today I will cover the basic concepts of understanding the states of matter. Throughout this lesson, I will present a set of questions to test your knowledge of the information. Feel free to pause the video if you need further time to answer the questions. Are you ready to get started? Let's go! States of matter. There are typically three states of matter that students tend to know about, but one in particular we will discuss that's little known. But the first state of matter is solids. Solids have a definite shape and volume. Here are three properties that you need to know. Particles are tightly packed and vibrate in place. Particles vibrate but do not move from their fixed positions. And solids have high density and are incompressible. Some examples of solids are ice, iron, and wood. The next state of matter that you need to be familiar with is liquids, or liquids rather. Liquids have a definite volume but take the shape of their container. Three properties that you need to know about liquids are particles are close but can move past each other. Particles of liquids are close together but not in a fixed position. And lastly, liquids have moderate density and are relatively incompressible. Some examples of liquids of states are water, oil, and alcohol. The next state of matter are gases. Gases have no definite shape or volume. Here are your three properties that you need to know about the states of matter specifically for gases. Particles are far apart and they move freely. Gases are compressible and they have a low density. Particles also move at high speeds in all directions. Some examples of gases are oxygen, carbon dioxide, and nitrogen. Here is that last one that I wanted to discuss, and that is plasma. People oftentimes don't think of plasma being a state of matter, but it is. It's the fourth one in this category. Plasma is an ionized gas with free moving ions and electrons. Now, do you all know where plasma actually resides? In the sun, lightning, and in those neon signs. Now, there are three properties that you need to be familiar with for this state of matter. Plasma conducts electricity and is affected by magnetic fields. Plasma also has particles that are charged and move at very high speeds. And also, plasmas are found at very high temperatures. Phase changes. You need to also understand that there are various phase changes when it comes to states of matter. For instance, melting. Ice melting to water basically means that you're going from a solid to a liquid. When you're freezing things, that simply means you're going from a liquid to a solid. An example of that would be water freezing to ice. Vaporization, that's when your liquid goes straight to a gas. So if you're boiling water for, let's say, some noodles, you're going to have vaporization occurring. Condensation, on the other hand, is when that gas turns to a liquid. So you get something like steam, which condenses to water. Know this chart because on the TEAS exam, we're going to ask you questions in terms of the different points. What we see here is called the critical point. The critical point, matter of fact, let me show you guys right here so that you are familiar with this. The critical point occurs when you have all three states happening at the same time, right there. So you have your solids, your liquids, and your gas happening at the same time. And that's why they call that the triple point. Make sure you are familiar with that concept as well. Elaborate on this important concept. The triple point is a specific combination of temperature and pressure at which all three phases of a substance, solids, liquids, and gases, coexist in thermodynamic equilibrium. At the triple point, the substance's molecules have enough kinetic energy to exist in all three phases simultaneously. Now, you're probably wondering, okay, Professor TK, why do I need to know this as a nurse? Understanding the triple point is important for nursing students because it provides fundamental insights into phase transitions and the behavior of substances under different conditions. This knowledge will help you comprehend bodily processes like temperature regulation, fluid balance, and the effects of pressure and temperature changes on medications and treatments. Okay, let's continue. To be more specific, when it comes to sublimation and deposition, students oftentimes forget that sublimation is when you have a solid that goes to a gas without passing through the liquid state. An example of this is dry ice, which you can oftentimes buy in the grocery store. Dry ice comes in a solid form, but when you look at it, there's little gas particles that are coming around it, and that is what we call sublimation. Deposition, though, is the opposite effect of that. That's when that solid goes to, I'm sorry, deposition is when that gas goes to a solid without passing through the liquid phase. An example of that would be frost forming on a cold surface. Quiz time. Let's see what you guys can remember from what we just covered. Number one, which state of matter has a definite shape and a definite volume? Is it solids, liquids, gas, or plasma? The answer is A, solids. Remember, liquids have a definite volume but take the shape of their container. Gases have no definite shape or volume, and plasma is an ionized gas with free moving ions and electrons. In which state of matter are the particles far apart and move freely? Is it A, solid, B, liquid, C, gas, or D, plasma? Hmm. The answer is C, gas. Remember, gases have no definite shape or volume. Their particles are far apart and move freely. Solids have a definite shape and volume. Their particles are tightly packed and vibrate in place. Plasma, on the other hand, is an ionized gas with free moving ions and electrons, and their particles are charged and move at very high speeds. And lastly, liquids have a definite volume but take the shape of their container, and while their particles are close, they can move past each other. Question number 3. What is the process called when a solid changes directly into a gas? Is it A, melting, B, freezing, C, sublimation, or D, deposition? The answer is C, sublimation. Remember, if you're going from a solid to a liquid, that's melting. If, on the other hand, you're going from a liquid to a solid, that's freezing. And lastly, deposition is the opposite of sublimation, where you're going from a gas to a solid. So, C, sublimation, where a solid changes directly into a gas, is sublimation. Question number 4. Which state of matter is characterized by ionized particles that conduct electricity? Is it A, solids, B, liquids, C, gas, or D, plasma? The answer is D, plasma. Remember, plasma is an ionized gas with free-flowing ions and electrons. Liquids, on the other hand, have a definite volume but take the shape of their container. Gases have no definite shape or volume. Solids have a definite shape and volume. Those other three examples do not deal with ions of particles that conduct electricity, only plasma. And remember, plasma also occurs in neon lights and lightning, just as you have two examples for those types of physical states. Kinetic molecular theory, KMT. The principles that you need to understand are particles of matter are in constant motion. The speed of particles increase with temperature, and particles collide with each other and the walls of their container. So you see there's an image on the screen. Make sure that you are familiar with this concept, because here's the thing. If you noticed here in the first container, when you have low pressure, look at how those molecules are moving about. When you have high pressure, notice that as well. And when the pressure is also still relatively high, notice what's happening in terms of those particles, okay? So again, keep in mind that the speed of the particles increases with temperature and that they collide with each other and the walls of their container, and they are in constant motion. Quiz time. What does the kinetic molecular theory explain? A, the behavior of solids only. B, the behavior of particles in all states of matter. C, the chemical reactions of gases. Or D, the formation of plasma. The answer is B, the behavior of particles in all states of matter. Remember, the kinetic molecular theory explains the behavior of gases in terms of particle motion. It states that gas particles are in constant, random motion, and the temperature of a gas is directly proportional to the average kinetic energy of its particles. And also, this theory assumes that gas particles have negligible volume, experience elastic collisions, and exert no intermolecular forces except during collisions. This theory helps to understand properties like pressure, temperature, and volume in gases, and explains phenomena such as diffusion and effusion. The heating and cooling curve is very important to know for your TEAS exam, and here's why. You're going to have to know how this graph works, because you will be given a chart similar to this where they're going to have you identify what each section means. So if you look at section A, B, C, D, and E, notice how they are outlined on this graph. They are curved or has like an arrows. So depending on what state they're giving you, they may ask you to indicate what's that section B, phase B. So you can either say it's melting or freezing, depending on whether you're adding or removing heat. Liquid, same thing here. They may have you identify what section C is, section D, and section E. Make sure you know this graph. Heating curve shows that the temperature change as heat is added. When you get to the cooling curve, it's going to show temperature change as heat is removed. Know the difference? A heating curve example is when you have like the solid phase. You're increasing the temperature. Melting point, constant temperature. Liquid phase, increasing temperature. Boiling point, constant temperature. Again, gas phase, increasing temperature. The cooling curve. The cooling curve deals with gas phases that have decreasing temperature. Condensation points have constant temperature. Liquid phases have decreasing temperature. Freezing points have constant temperature. And solid phase decreasing temperature. What I recommend in order to know these different phases here, use what I call note card chemistry, where you write those things down on note cards and the phases for cooling examples, cooling curve examples versus heating curve examples. That way you will know the difference, because you know at the end of this there will be a quiz that I will ask you questions about them. Here are some heating curve examples. Again, there's a chart here where you see A, B, C, D, E, and F. Again, you'll have to be able to know how to interpret this data. So if you look at the solid phase, that means you're going to increase temperature. The melting phase, that means your temperature is constant. The liquid phase has an increase in temperature. Boiling point has a constant temperature. And the last part of the phase is the gas phase, that's increasing temperature. Here are some real life examples of phase changes. For instance, if you have melting, that ice melting on a hot day, of course that's going to be the melting phase. When you talk about freezing, water freezing in a freezer, vaporization, an example would be water boiling in a kettle. Condensation, dew forming on grass. Sublimation, that's when you have dry ice being used in fog machines. And deposition is when you have frost forming on windows. What happens when heat is added or released? When heat is added, particles move faster, temperature increases, and phase changes occur. Melting, vaporization, for instance. If heat is released, particles slow down, temperatures decrease, and phase changes occur. Freezing and condensation. T's question time. Question number 6. On a heating curve, what happens to the temperature of a substance during a phase change? Is it A, it increases, B, it decreases, C, it remains constant, or D, it fluctuates? Hmm. If you chose C as your answer, it remains constant, you are correct. During a phase change, such as melting, solid to liquid, or boiling, liquid to gas, the temperature of a substance remains constant. This is because the energy added to the system is used to break the intermolecular bonds rather than increasing the kinetic energy, meaning the temperature of the particles. A, it increases. This is incorrect because during a phase change, the temperature does not increase. The added energy is used to change the phase by breaking bonds, not to increase kinetic energy. B, it decreases. This is incorrect as well because during a heating process, energy is being added to the system. The temperature cannot decrease while energy is being continuously supplied. And finally, D, it fluctuates. This too is incorrect because the temperature remains steady and does not fluctuate during a phase change. Fluctuation would imply irregular increases and decreases, which does not happen in a controlled phase change scenario. Okay, let's keep going. Question number 7. Which of the following is an example of deposition? A, ice melting into water. B, water vapor forming frost. C, dry ice turning into carbon dioxide gas. Or D, liquid water evaporating into steam. If you chose B, water vapor forming frost, you are correct. Ice melting demonstrates going from a solid to a liquid. C, dry ice turning into carbon dioxide demonstrates sublimation. And D, liquid water evaporating into steam, that demonstrates evaporation, meaning you're going from a liquid to a gas, aka steam, and that demonstrates evaporation. So B is the only answer that indicates what deposition is, which is to convert a gas into a solid, which in this case, the water vapor forms into frost. And our last question. During a cooling curve, what happens to the temperature of a substance when it changes from a liquid to a solid? Is it A, the temperature increases, B, the temperature decreases steadily, C, the temperature remains constant, or D, the temperature fluctuates? The correct answer is C. During the phase change from liquid to solid, meaning freezing, the temperature of the substance remains constant. This occurs because the energy being removed from the system is used to form intermolecular bonds and organize the molecules into a solid structure rather than decreasing the kinetic energy, meaning the temperature, of the particles. Now, if we look at the other answer choices, A, the temperature increases, that is incorrect because during a cooling process, energy is being removed from the system. The temperature cannot increase while energy is being continuously lost. B, the temperature decreases steadily. This is incorrect because while the substance is changing phases from liquids to solids, the temperature does not steadily decrease. It remains constant during the entire phase transition until all the liquid has turned into a solid. And then finally, letter D, the temperature fluctuates. This too is also incorrect because the temperature does not fluctuate during a controlled phase change. Fluctuation would imply irregular increases and decreases, which does not occur in a phase transition from liquid to solid when the process is continuous and uniform. Now, we did discuss this also as it related to the heating curve as well. Keep this in mind also for your TEAS exam. Remember, understanding the properties of matter is crucial for grasping advanced concepts like solubility, chemical reactions, and phase changes. And you're going to see this stuff along the way throughout your process of learning this material. Polarity and bond types help predict solubility and reaction outcomes. Temperature, pressure, and concentration influences reaction rates, while physical states affect the speed of reactions. So, having knowledge of these intermolecular forces explains phase changes and boiling and melting points. Additionally, understanding acids, bases, and buffer systems is vital for maintaining pH stability in various systems. So, this fundamental knowledge allows for accurate predictions and explanations of complex chemical behaviors and their practical applications. So, everything that you're learning in this chapter forward, this unit forward, is going to help you do well in understanding how all of these different topics intercomminglate with each other. Understanding the principles of kinetic energy and the various states of matter is fundamental to mastering chemistry. The behavior of particles in solids, liquids, gases, and plasma, along with the concepts of phase changes and the kinetic molecular theory, provide concepts that are not only explain everyday phenomena, but also play crucial roles in scientific and industrial applications. To understand the heating and cooling curve graph, that's also necessary as you guys prepare for the TEAS exam. So remember that a solid grasp concept of these basic issues will be instrumental in your success and future studies in the field of healthcare and beyond. Good luck on your TEAS exam. Stay tuned for our next video where we will assure you that you can pass your TEAS exam with flying colors.